Next up, we have Kent Gee from Brigham Young University to talk about Falcon 9 ascent sonic boom measurements in Ventura County. All right, go ahead.
All right, thank you, everybody. This is a little bit of a change of pace from the prior two talks, but it has kind of the same goal in terms of protecting our stewardship over our environment and understanding our relationship with it. This is a little discussion of the talk that was given yesterday by my student, Michaeli Kellison, and it deals with the measurements that we made last summer in Ventura County, California, of these Falcon 9 sonic booms. The work has been sponsored by the Space Force as they're trying to understand the potential effects of these booms. And so we call our project EcoBoom, thanks to ChatGPT for the logo, but which stands for Environmental and Community Observation of Sonic Booms. And these rocket launches, this is what you'd see from Ventura County for a dusk launch, right? They launch from the base to the north, they fly towards the south, and you're looking west here, and you would see the vehicle's path, and so everyone's kind of sees the same thing, but what you hear depends on where you're at and the rocket's path or trajectory. And so just to orient you in terms of California, right, this where it says Space Launch Complex 4, that's up on Vandenberg, Slick 4. That's there at the top left corner of this map. And then as you go down that coast, you have Santa Barbara, and then Ventura, and Oxnard, and then you get down towards Malibu. And so when the rocket launches, these Falcon 9s launch, one of the trajectories they might take for when the Starlink launches is about 140 degrees. Okay, so it flies over the Channel Islands, and the sonic boom, as it flies supersonically, it impinges kind of on it as it accelerates and pitches over. The sonic boom impinges at some point, and we refer that as the focal point or the boom cutoff. And so it's kind of a parabola shape. And then that boom kind of propagates as the vehicle moves farther south along its trajectory. That boom is present along its carpet, say in Ventura and Oxnard. And so that's not the only trajectory that might be flown. If you change the trajectory, you also change the potential boom location. And so we're trying to understand the effects of trajectory, meteorology. How does the weather play the role in the boom as it propagates from the vehicle to the ground, and local measurement environment? And so to do that, because this hasn't been studied very well, we made these measurements. And measurements were made in parks and people's backyards and school parking lots and wastewater plants and all sorts of different locations, as we were trying to find just areas where we could set up and our equipment. And so we use specialized equipment suitable for recording these very low frequency events. And so what do I mean by low frequency? And so we have things that go bang, and this is an example of a sonic boom recorded at Oxnard High School. This bang, when you look at the units of this, first of all, it lasts a few seconds in terms of its overall duration. It's very low frequency. We usually think of acoustic waves as lasting milliseconds, thousandths of a second, and this is lasting a few seconds. So it's very low frequency, and can be potentially mistaken for a seismic type event, which Californians are particularly sensitive to. If you're indoors and it shakes your house. But this overpressure, which is measured in pounds per square foot, in this case, it approaches 2 pounds per square foot, which is 133 decibels. And so, but a very low frequency event. And so can really provide a good bang outdoors. Now, if you just look at that little arrow that appeared on the screen, that's going to be the vertical axis for the next plot. Okay, and sometimes you get a very low amplitude rumble, But it comes on suddenly, and then it's there for a few seconds and disappears. Again, possibly mimicking an earthquake type event. And so it can cause concern, particularly if people are woken up at night. Now, this gives you an example of one of the results that we measured from one of the Falcon 9 launches. And just to orient you, again, so if the vehicle isn't fast enough or traveling with the right heading, you don't see a boom. And so that's what that X represents. No sonic boom there. And then, well, everywhere to the south of that, we now see some form of sonic boom. Now, you kind of grow in level. The color on the right there, that color bar, right, it goes from blue to red, and white being very low amplitude, and black then being the highest amplitude. And so you hit a focal region. There's a region there in Ventura and Oxnard and Camarillo where the booms are particularly are more impactful. And then everywhere outside that, it's relatively low amplitude. And where that focus occurs changes launch to launch, even for the same trajectory, indicating the role of meteorology. Now, what happens if you change from a 140-degree trajectory to that 155, swinging it from more east to a little bit more south? And for that launch, we measured basically nothing. And so trajectory plays a really important role. And so the idea exists that you could, if you can change your trajectory even a little under the right meteorological conditions, you could have a big impact on these sonic booms in this region of the country. So we've measured from 0 all the way up to a pretty good bang at almost 2 pounds per square foot. And then we're starting to look at these effects of what will you hear, what's it determined by, and will it be more of a bang, a thump, a rumble, or nothing at all? What you'll hear inside versus outside, and how much does your ambient environment influence it? We're not done with this. We've started a much more extensive campaign. The results that we presented here at this conference are just the beginning of it, and so we'll have much more to share in the future. Thank you.
Thank you so much. Yeah, go ahead.
Sure. Yeah, thank you. Vandenberg's been launching military rockets for a very, very long time. Mm-hmm. So is there anything special about the Falcon 9 launches that have created this concern, other than that they fly much more often than the military rockets?
I'm going to go back to a map here. Yeah, okay. So, typically, because you're flying over the ocean almost immediately, I mean, that's why Vandenberg exists. It's a very convenient location. But and a lot of the trajectories typically have been to the west or to the south. Okay, that's where the typical launch, because again, you go over the ocean. Now, because of the Starlink satellites, right, and some of the military missions as well, the orbital mechanics for where they're trying to place these into orbit dictate you have to fly within certain orbits, and it's getting them closer to the coast. And so, and there seems to be potentially different times of year and things like that could be more impactful than others. It's a great question. And the frequency of the launches are increasing, right? Back in the 80s, Vandenberg launched maybe 2 or 3 rockets per year on average, right? And now we're talking at least, right, 5, 6, 7 rocket launches per month.
I'll go ahead and ask a quick question because I have some really cool insider information on this one. You said this is work done with Space Force. So can you talk about the work that is being done with Space Force to present this data and why they're interested in it?
Yeah, so Space Force is interested in this because they have they feel a sense of stewardship, right? They want to be good neighbors, good partners with the community. These rockets from SpaceX and other providers are launched from the base for a variety of missions, and they want to understand the effects on both on base and off base. And so we were doing a previous project on base and looking at ecological effects of these rocket launches on base, marrying physics and biology, trying to understand what those impacts might be. And then we were asked by the base to see if we could pick up our equipment and move south, some 60 miles south, and start making these kinds of recordings And that was just to try to get a sense of what was going on. And there are, the base is working with the community, working with Congress, working with various people to try to, and SpaceX and other providers, trying to understand how they can complete the mission and minimize impacts.
Thank you. Go to some online questions now.
Yes, we have a few here, and this first one I feel like ties into what you were just saying. It's from Avery Thompson, and Avery asks, could this work support the development of local regulations or noise ordinances to minimize the effect of these launches on residents?
I think that's a great question, Avery, and I would say yes, in a very preliminary sense, right? We are just gathering data. No two launches look the same right now. We're trying to understand. We think, we just measured over here, and now we're going to increase the amount of equipment that we're using over in this area, and then it moves again. And then, it's literally like trying to catch lightning. I mean, you're looking left and right and up and down, and so, but we're getting a sense of kind of the overall scale of what's going on. I think the biggest questions then rely as what's acceptable, what's impactful, and those start to become more social questions, right? Subjective questions, and I think that's where the conversation eventually is going to need to go, and what metrics should be used to gauge those things, and so the data we have can be used in support of that work, but not as a complete replacement.
Thanks so much. Just a couple more here. One is from Jessica Sansarin, and she's asking, are there plans to study this in Florida too?
That's a good question. Now, most Florida launches occur relatively east, so they are heading out over the ocean. But there have been some launches that have been more to the south recently. And so is it possible that they're going to start seeing more sonic booms along the coast there? I don't know of the plans to launch, all their launch trajectories. I do not personally have any plans for that, but it's something we could be watching carefully. And I think some of our findings on the West Coast should apply to the East Coast as well.
And one more geographic question.
Sure.
This one's from Anashay Bhandari. Anashay says, Californian here. Maybe this is out of the scope of this work, but you mentioned the rumbling may feel a little like an earthquake. Given that Ventura is earthquake country,
Right.
Are there any concerns that one might become acclimated to the rumbling or confuse one for the other or not take appropriate actions?
It's always fun when people find additional significance of your work. That's honestly not one I had considered. It's actually interesting because we have, since we're setting up in some people's yards and their backyards, they're often texting us the results of what they heard. It's a fantastic citizen science, right? And they will tell us the difference is that, the walls shake, but the floor doesn't shake. It's they're thinking, it's an earthquake, and they're able to tell the difference. They're starting to be able to tell the difference between the two. I think sometimes it's like, what did I just get woken up by, right? But once they realize what's going on, they're like, okay, wait, this is an earthquake, this is a sonic boom. But they're kind of in a similar overall response. So anyway, it's an interesting question. I don't live in California, so I'm not certain of all of it, but at least the people we've talked to seem to be able to distinguish ultimately the difference between the two and whether or not there's a genuine concern.
And I have one last question. You
Sure.
mentioned it can vary with the weather. So are there interdisciplinary studies or research going on with acoustics and meteorology?
Excellent question. The Space Force just put out a press release about a partnership between the Space Force, NASA, SpaceX, BYU, and our partners in this Cal State Bakersfield. We're all working on aspects of this problem. And one of that is to model these sonic booms under different meteorological profiles. One of the challenges, though, if you've ever driven along that California coast, is the weather changes, dramatically. You go from fog to sun to fog to in just miles. And so in that 60 miles from the base, you can go from complete fog at Vandenberg to complete sun in Ventura County. And so there's a lot of work to be able to do to understand all of those meteorological impacts in a very local area.
Thank you so much. Appreciate it.
All right, thanks.